Uh, can I divide like the 12 by 6 or something?
Yeah.
So that's 30.
So, so that'll be 2. Okay, what next?
Um, can I divide the root 8 and 4 by 2?
Uh, okay, what is... no, you can't because they have powers. And so because of bidmus, you would have to deal with the power first. But because we don't know what y is, you can't do that.
Okay. Um, do I need to find like something in common with 2y plus 1 and 2y plus 2?
No. So the big picture is, like I said, show that can be written in the form 2 to the power of p. So the big idea is you write everything as 2 to the power of something.
Okay. Um, is it, wait, so if it's 2y divided by 2y, is that just like 1?
So you're on the right track, but there's a lot more than just a 2y there.
Yeah.
And they have to have the same base. So it'd have to both be yeah, the big number would be the same, like 4 and 4 or root 8 and root 8.
I'm not really sure how to do.
So let's say root 8. Could you write that as 2 to the power of something?
2 to the power of 2. Oh no, 2 to, oh no, sorry. 2 to the power of 3.
So that's 8. And so what is square root to the power?
Um, isn't it 2 square root to if 2 or something?
Um, like let's say the square root of okay, so 8 is 2 root 3.
Okay.
Sorry, 8 is 2 to the power of 3. So that's the same as the square root of 2 to the power of 3. How do you write square root as a power?
Do you put a number? Do you put a number in front of it?
No. So square root of any number is the same as that number to the power of something.
So, oh, minus 1.
Close. That's 1 over a.
Oh, is it minus a half?
Just a half.
Alright, okay.
So root 8. So 8 is 2 root 3.
Yeah.
So root 8 is the same as the square root of 2 to the power of 3. And that's the same as 2 to the 3 to the half. How would you simplify that?
Um, is it 2 to the power of 1.5?
Yes. And I'll leave that as 2 to the power of 3 over 2. Okay, so that's 2 times 2 to the power of 3 over 2. And then you have that 2y plus 2. Okay. How would you write the bottom as 2 to the power of something?
So 1 times 4.
So I can leave out the 1 times, that'll be the same thing. Let's say the 4. What is that as 2 to the power of something?
2.
Yeah. And so 4 to the power of all of that stuff is 2 squared to the power of all of that. 2y plus 1. So what's next?
I need to do the 2 bit on like the square bit times 2y plus 1.
Yeah, well done.
So okay, so for the first bit where it's 3 over 2 times 2y plus 2, is that like 6 over 2?
Mm-hmm.
What 6 over 2y plus um plus 6 over 2,
Yeah. And what
which
is?
is
Yeah.
oh, and do I do a second bit under or
Yeah.
and then 2 squared is going to be 2 per power of 4y plus 2.
Yeah. Anything you can do there? What'll be next?
So can I do like 2 divided by 2? So from the top bit, from the numerator to the denominator, I'm allowed to do that.
I think you should multiply first.
Alright, okay. So yeah, 2 times 2 is 4.
Well, you're multiplying indices. 2 by itself is to the power of what?
1.
And so how would you multiply those two?
So 1 times 6 over 2y plus 6 over 3.
What is 6 over 2?
3 over 1.
Yeah. Even simpler.
3. Oh.
So that's 3y plus 3. What's the rule for multiplying indices?
Oh, they add up together when you like, don't they?
Yeah.
So is that going to be? Wait, I'm not sure if I'm allowed to do like the 3y bit because it's not like in because it's got letters in it.
Yeah, it's all the same.
So is it 4y plus 4?
Yeah. What do you do next?
Wait, isn't it 4y or was it 3y?
It was 3y. 6 over 2 is 3.
So
And 4y was on the bottom.
so it is where I need to actually start dividing it.
Yeah.
Okay, so like so 2 divided by 2 is 1.
No. You're dividing indices.
Oh, right. So wait, that's like y plus or minus y plus 2.
That's it. Minus y plus 2. And that's what they wanted, 2 to the power of p. And so, yeah, p is minus y plus 2. So, any questions there?
No.
So, very difficult one. The big picture is they want it as 2 to the power something. So just keep making everything 2 to the power something. 2 by itself, like 12 over 6 is 2, which is the same as 2 to the power of 1. Root 8 is the same as 2 to the power of 3 over 2. And just keep doing that. Multiply indices, power to power, divide indices over and over with very strange algebra.
Yeah.
Okay, how do we go about this?
Okay. So. Do I need to like fill in like the histogram on the left to help me?
So that'll help, yeah.
Where it says 80 of the farms have a size of 20 hectares or less, does that mean that it'll be 4 where the little hectare bit is?
Yeah, so like that, is it?
Yeah, and then you can see it goes up in like ones. I think it's just 1, 2, 3, 4, 5,
Yeah.
and then 20% of the farm's size. And then it says like a fifth of the farms with a size of 100 hectares or less grow wheat.
What do you do there?
So do I say something like, okay, well, so 80% of 100 hectares or less grow wheat?
Yeah.
Right.
Oh, sorry, we want the ones that do grow wheat. So how do we find the number 100 or less that grow wheat?
Well, I just need to times like for each like little bar in the histogram.
Yep.
Okay, so yeah, so 4 times 20 is 80,
Mm-hmm.
and then 3 times 50 is, oh no, sorry, 3 times is that 30, isn't it?
So yeah.
Yeah, so 90, and then 50 times 2 is 100. I think that's all I need from that, isn't it?
Mm-hmm.
And then do I need to add that all up and then divide it by 5?
Yeah.
Alright.
Okay. 17. 10 divided by 5. I believe it's 54.
Okay. And then 3/4 of the farms with a size of more than 100 hectares grow wheat. So and then with the size of 100 hectares grew. So do I now need to do the other two bars?
Mm-hmm.
All right, and that's 20 times 1.5, which is, I've got a calculator, 30. And then for 120 to 150, that's like, so yeah. Sorry, so 30 times 1 is 30. And then do I need to do 60 times 3/4?
Mm-hmm.
And I think that's 45.
Yeah.
Um, uh, yeah, the thing is, I'm a bit confused because it says like 80 of the farms are the size of 20 hectares or less, and we've got like above 80 here.
So basically, that just was the key for us. Like 80 of the farms have 20 hectares or less. So we kind of found that there. So basically, we found everything now. So 54 farms, less than 100 hectares, grow wheat. 45 farms above 100 hectares grow wheat. And now we want the total number of farms that grow wheat.
So is it just 54 plus 45?
Yep.
And so 90, 99.
Yeah. Got it. Any questions there?
No.
Okay, so you're good for histograms. Okay, how about this tricky one?
This is definitely my last topic. You should do that, thanks. Um, so is it just like 6 plus 2 AV or something?
So I might make it a bit simpler.
No.
Is if we call this x and this 2x for the moment. And so going in terms of 2x, what would it be? Or in terms of x, what would it be?
2x plus 6.
And what about 2x plus 6? So that would, okay, so that would be PD. You'd have to put that into some kind of a sentence. Or in some kind of equation. You might not know it.
I'm not sure.
So for this one, because you've got two chords that meet at the point, excuse me, it's the 6 part times by the total of that line, 6 plus 2x. Oh, I'll write it as 2x plus 6. So 6 times the total of its line. I better just for space. 6 times 2x plus 6 will be equal to the part of the other line times its total. So any idea about that?
So do I have to expand the brackets?
So before you expand it, what would be for the other line? Something similar to this.
Is it 6 and then x plus 7?
So it's going to be x plus 7, but it's not 6. That's the outside part for the other line.
Is it 7?
Yeah. So it's like similar lengths. And then you would solve this. So it's like this part times the total equals this part times the total. Yeah, how do you solve this?
So if I expand the brackets, it's like 12x plus 36 equals to 7x plus 49, and then and then if you do 12x minus 7x and 49 minus 36, that will be 5x is equals to 13.
Yeah.
And then x is equals to 13 over 5.
Yeah. I think it's 2.6. Don't think it matters. Okay. Is that what they were looking for?
No, they're looking for 2x. So is it just 2.6 times 2?
Well, they wanted PD. CD is 2x.
CD is 2. Oh, right. And so they're looking for 2x plus 6.
Yeah.
So is it 2 times 2.6 is 5.2.
Yeah.
And then 5 plus 6 is 11.2.
That's it. Well done. So if you've got two chords that meet at a point, one part times the total is equal to the other part times the total. So from the point of intersection to the point where it meets the circle. Any questions there?
How did you know that the top bit x was half the size of the bottom bit 2x?
Oh, sorry. This thing here. DC equals 2AB. So you have to times AB by 2 to get DC.
Oh, right. Okay.
Yeah, sorry, I assumed that you noticed that already.
No.
Okay, how about this one?
Okay, so do I have to complete the Venn diagram first?
Yeah, part 8. I just kind of squashed them all in.
So, um, So does that mean that the missing number has to be 6 or something?
Which one is missing?
Not so A and then the little comma thingy, so like not an A.
So where do I draw a 6?
I don't know, like just anywhere outside A. Like I don't know. I thought you were doing like in the ABC or something.
So outside of A includes here, 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 and here.
Yeah.
So where will it go?
Um. I'm not sure.
So these 3 are already done, so it'd have to be this one.
Yeah. Okay.
Okay.
And then, do I need to do the A and C equals to 9 now?
Mm-hmm.
So. Is that going to be 7 in the A and 9 bit?
Yep. Okay. Part B.
Okay. And then find. So I think for the A bit, it'll be like 8 and 3. And so, wait, can I include 2 and 7 because it's not like part of the B and C bit?
So I would do the bracket bit first. So let's say, what are the elements of B?
4, 0, 2, 3.
4, 0, 2, 3. Okay. And how about this bit, the not C?
So 5. Is that part of it? Because it's nice, yeah.
Yeah.
4, 3, 8.
Yeah. And so, what would be this one that they gave us?
So 4 and 3.
Yeah. Okay. And so it's A union that, and so it's what is going to be the whole thing. Or let's say, what is A?
8, 3, 7, 2.
And then so, how about the total thing
then? 20.
For like the question that they're asking us, A union.
Oh, is it 20 plus 4 plus 3?
So what would be the elements first? So, okay, yeah. So the end of it would be, okay, 20. Yeah, because 4 and 3. Oh no, spoke too soon. So you know how A has 8, 3, 7, and 2?
Yeah.
And what does the other one have?
4 and 3.
And so what will be the union of the two?
3.
That would be the intersection.
Oh, the union. Would that be? Is that just all of the elements?
Yeah.
8, 3, 7, 2, and 4.
Yeah. And you just don't count the 3 twice. And those are what you add up.
And then that's a 24.
That's it. Okay. So, and then the next part, I'm just going to have to make more room. Oh, you've lost the question. There it is. Okay, how about this one? And you can do something similar if it helps, or doing it right.
So shall I do what we just did now, and then write out what's in A, what's in B, and then like the not B bit, and then A and C again?
Yeah, and okay.
So in A, there's 7, 2, 3, 8.
Let's try to do A union C in one go.
Cool. Oh, that's just going to be 7. It's all of A plus all of C, isn't it?
Yeah. So what is that? And just keep them as the separate elements for now.
26.
I would keep them separate.
8, 3, 6, 7, 2, 0.
Yeah, and I think I can leave out the 0. Okay, and then let's do these. Okay, so what is, let's say, not B?
So
just a sec, sorry. Go on, just keep going with that.
A chocolate egg.
You have to read a bit. I have to finish the okay. Sorry about that. Yeah, not B.
So I think that's just 5, 6, 7, and 8.
Okay.
And then because it's or and not and, does that mean that I just add up all those numbers together?
Well, was that A union not B or just not B?
It was A. Yeah, it was A or not B, I think.
Oh, okay. So hang on. And now there's a number missing. If you were to have all the numbers in A as well. So not B was 5, 6, 7, 8, and so that with the union, that union A.
So I need to find A now.
Yeah, and add them in there.
Yeah. So 3 and 2.
Okay, go on.
And then now, do I need to find what numbers they have in common?
Yeah, exactly. Yeah.
And that's 8. Yeah, so 8, 3, 6, 7, 2.
Mm-hmm.
And then that's going to add up to be, I think that's 26.
Well done. Okay, any questions there?
No.
Okay, all right for those. Okay, this one, yeah. Take a look here. Probability isn't too tricky. This. Okay. Or is that there? Okay, let's try this one.
Oh. So I need to find the area of a cylinder and the area of a cone, add it up, and then see like where the 9 litres of water stands in it.
Yeah, exactly.
Okay. So, I don't know. I don't think I remember the formulas for those. I don't know if they're given to you, but I don't remember them right now.
So this one, what's the area of the top of it?
Pi r squared.
And so it's that times the height for the
Yeah.
volume. And any idea volume of a cone?
So wasn't there like 3/4 or something like that? Something.
1/3.
Oh, 1/3. Sorry.
Yeah, a cone is 1/3 of a cylinder, and so it's 1/3 times same thing. Okay.
I'll do cylinder first.
Okay.
So pi times 15 squared times 20,
Okay.
which I think is pi times 15.
And
Yeah,
I'd leave it in terms of pi.
yeah, yeah. It says here it's 4,500 pi.
Okay, so that's the total what you could fit into the cylinder. Okay.
And then for the cone bit, it's a third.
Mm-hmm. You could just do a third of that.
I think it's 1,350 pi.
Yep.
And then if I add them together,
So
yeah, I'm sorry.
now we're told you have 9 liters.
Yeah.
So how many liters would be the cone?
How many liters? I don't know.
So then you could convert that. So 1350. What what number is your calculator?
Like where does it say the number exact? Sorry.
Like at the top somewhere like FX.
Yeah. So FX 85 GC.
Okay, so it's similar to this one. So let's say 1350 pi is this. So these are centimeters, which are similar to milliliters. So let's say 9 liters is 9,000 milliliters.
Okay.
So the 9,000, take away that. Okay, so the first, let's say 4758.8. So 9,000 minus this much, minus the cone, leaves us with this amount of water.
Yeah.
Okay, so we're trying to find out the height the water goes to in the other one. So it fills the cone, and we're trying to find the height that it goes to in the other one. Any idea about that?
So what the difference of 9,000 and 475? Okay.
Well, I just did the difference between 9,000 and 1350 pi, because that basically fills up the cone. So there's 4758.8 left over.
So then do I need to do 4,800 pi minus 475 8.8 or
No, you need to use some equation with the cylinder that has volume and height. This pi stuff is volume, and we want the height.
I don't know. Do I have to do like 475 8.8 divided by 20 or something?
So the formula that we have is this one. And
Can I work to get the height?
Yeah. So what would you sub in where?
So, oh wait, do I have to? Is this where I have to like start like getting height on its own or?
Yes.
Oh, cool. So can I just take the pi off? Can I just do v divided by pi r squared to get the height?
Yeah.
And then so the volume is 500 pi.
Yeah, the volume of the water remaining.
And then and the volume is pi times 15 squared.
Yeah.
And then do I just put that in my calculator?
Yep. That's it.
Yeah, and then and then to 3 sig fig, I think that's 6.73.
Yep. 6.73 centimeters. And does it look about right?
Yeah, probably.
Yeah. If you got an answer like 21, you'd know it's wrong.
Yeah.
So for this one, you use pi r squared height and 1/3 pi r squared height, and then you end up having to rearrange it to using volume over pi r squared. Yeah. All right. Any questions with that one?
No.
Okay, so we just had to subtract a volume first before rearranging it, because only some of it was in the cylinder. Okay, how about this one?
So. So do I need to like try and find all the possible numbers he could get, and then like find a fraction of the probability that he gets a number?
So I think if you list the successful outcomes first, so how can you get an odd number, and then go from there?
So yeah, so if he gets one, so he can't do it with three even numbers.
Yeah.
If he gets two evens and an odd,
So, okay, so what would they be?
so 2, 2, 5.
Yeah. Any other way you could do it?
5, 5, 5.
5, 5. Okay. Probability of getting 5, 5, 5? To get 1, 5 is like 6/9, Yeah.
and then does it go down then to like 5/8, and then 4/7?
Yeah. And what do you do with those?
I'll multiply them.
Yeah.
And then that'll be
So let's see what the calculator says.
I've got a calculator.
Yeah.
So,
So I think the calculator will simplify it.
is it 504? And then do I need to simplify that?
You don't have to.
Okay, cool. And then do I do the same thing for 225 now?
Yeah.
Alright, so the probability of getting a 2 is 3/9.
Yeah.
And then 2/8. And then 1/7. Oh, sorry, that's a 5. That's a 5.
Oh yeah.
And then 4/7.
How many?
Oh, no. 6/7.
Yeah.
And then I multiply those together. So 5/4, and then 3 times 3 times 2 times 2. 36/5/4.
And then?
Do I add those two numbers together?
Not just yet. You know the way you could get 2, a 2, and a 5?
Yeah.
So that's the same as 2, a 5, and a 2?
Yeah, it is.
And that's the same as a 5, a 2, then a 2. You end up with 2 2s and a 5?
Yeah.
And those will be the same.
Yeah.
So what would you do there?
Oh, then you just add. Do you just add those on to the other bits as well?
Yeah.
Okay. Is there any more combinations than that?
I don't think so. Either 5 is at the end, or the middle, or the start.
So, can I add the numbers up now?
Yeah, go on, what are you adding up?
36, 36, 120, and 36.
Yeah, or you can do 36 times 3,
Yeah.
and then plus the 120.
So I think that's 228 over 504.
Okay, what was it, sorry? 2?
228 over 504.
That's it. Okay, so any questions about this one?
No.
So just the last bit to watch for here. So these were 3 5s, so there's only, you can't do anything with those.
Yeah.
But then this one, it's 5 can be the last one, or the second one, or the first one. And so there's going to be 3 times as many chances for that. And so you times that by 3 and then add it on.
Yeah.
That's how that one works. I don't think we have time for this crazy stuff. We'll go for it. Okay, how about this?
So this is real where it's like y equals mx isn't or kx, sorry.
Yeah.
So is it v is equals to k times 60 times, so v equals to k and then root e,
Yeah.
and then that'll be 30 equals to k times a, I think.
Yeah.
And then do you do 30 divided by 8 to get k?
Mm-hmm.
And then that's 3.75. And then it says find the value of v really 400. Do you do 3.75 times root 400 to get v?
Yeah.
And that's 75.
That's it. So that didn't give any problems. Okay. Crazy stuff. For next time, sorry. Yeah, okay. How do you go about a question like this?
So you make everything into like powers, and then you use like indice laws or something to get the answer.
That's basically it. And in this case, 2 to the power.
Yeah.
And don't be afraid, because it's like, well, that has y's and that doesn't. It's just, you still just add the powers together. 2y plus 2 plus 1. You still subtract the powers. 3y plus 4 minus 4y plus 2. Let's do it as normal. This one I think you're mostly fine for, to be honest.
Yeah.
So what was the trick with this one? At the very beginning was the only part you didn't know.
Yeah. So so first, so fill it in obviously, and then because it was a chord or something, so the bottom line and the top line are equal to each other. and then so when we put in the x and the 2x bit, we could just write 6 and then 2x plus 6 and then equal to 7, x plus 6, and then just go from there. So
yeah, and so it's like the part on the outside times the total of its line is equal to the part on the outside times the total of the other line.
Yeah.
That's the kind of big thing there. So 6 times 2x plus 6 is equal to 7 times x plus 7. And then you go from there. I think you're okay for the Venn diagram one.
Yeah.
And then this tricky one. Okay. So you didn't need to find the total volume for the cylinder.
Yeah.
You were told, so basically it's 9,000 milliliters, which is like 9,000 centimeters. It's similar when you convert them into volume. Let's see. So you have to say what height it reaches. So height is v over pi r squared, The trick with this one was you just had to first subtract the bit that gets used up by the cone.
Yeah.
And to do that, you subtracted the volume of the cone from 9,000 first, and then you subbed in what was left over into the height formula.
Yeah.
That was about the size of that one. What was the one trick for this one that you missed out on?
I'm not exactly sure what to say, but you just need to like sort of find the different combinations and then like times them together. Once you find how often each one's possible.
Yeah. So basically, there were like 3 different combinations for it, and that's because you could have 5 in 3 different parts, and basically 2, like the 2 twos doesn't matter because 2 they're the same thing.
Yeah.
And that's why you didn't get, like, you could have gotten a total of 6 combinations, but because the 2 twos are the same, it's half of that, and so it's 3 combinations. Yeah. Oh, and then this one didn't give you any problems. How was that for you, Andrey?
Yeah, that was pretty useful because like those are probably the hardest topics for me anyway. So that was good.
Okay, so those are like, I think from the hardest questions for 2 different years. So do you want to keep doing this type of thing?
Yeah, definitely the hardest questions, please.
Okay. Yeah, sorry about this morning. I thought the lessons are at 9:30 for some reason. Any questions for you in general?
I don't think so.
All right. Well done, Andrey. You're doing great. Look forward to chatting again next time.